Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video, another video in our series of videos dealing with coordinate geometry of the line. This time is going to deal with calculating the perpendicular distance between a point and a line. Okay, so this particular example, let's say for argument's sake, okay, that we have an x-axis. And let's say we have a y-axis, okay, and let's say that we have a line that has positive slope. Okay, here's a line with positive slope. Okay, let's say L, and let's say for argument's sake that L has the form. It's, let's say, 4x minus 3y. Let's say plus 4 is equal to 0. Okay, let's say is equal to 0. Okay, so there's a positive sloped line here. Okay, and let's say we have a point. The point, let's say, is let's say the point is over here somewhere. Let's say the point is 7, 7, 2, let's say for argument's sake. Okay, and what we'd like to do is we'd like to calculate the perpendicular distance between the point and the line. So we'd like to calculate how far this particular point is away from this particular line here. Okay, and in particular the perpendicular distance. Okay, so we have a line L and we have a point 7,2. So maybe this would be something like this: given the point 7,2, okay, and the line L defined as 4x minus 3y plus 4 is equal to 0. Okay, calculate the perpendicular okay, distance okay, between the point and the line. Okay, so the first thing to do, is to always to plot the line, okay, and then to plot the point. Okay, so when you're answering these questions, it's nice to actually visualize what they look like. Okay, so here's the line L, and here's let's say the point 7,2. So why don't you go off and why don't you plot the line, and why don't you put the point relative to the line and show what you mean by the perpendicular distance? Okay, and then let's use the formula. The formula says, okay, which is really straightforward. The formula says that the distance, okay, that this distance here, d, okay, is simply equal to the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. That's the square root of this here. Okay, so all we need to know is the coefficients a, b, and c. Okay, the coefficients of the line. So given the line ax plus by plus c is equal to 0. They're the coefficients a, b, c. We have a 4 minus 3, 4. Okay, so all we need is the coefficients a, b, and c, and we need a point x1, y1. Okay, here's our point x1, y1. Here's our a, here's our b, here's our c. So we can actually just substitute them into this formula, and we have our solution. Okay, so this becomes the absolute value of a, which is 4 times x1. x1 is 7, so 4 times 7, plus b, well, b in this case is minus 3, so it's minus 3 times y1. y1 is 2, okay, and it's going to be plus our c, the constant term in our equation of our line, which is actually a plus 4 here, so it's going to be plus 4, and it's the absolute value of that divided by the a squared. Well, the coefficient of the x term here is 4, so it's got to be 4 squared plus the b value. The b value is minus 3, so it's minus 3 to be squared, and it's the square root of that, so it's the square root of that term there, right, which gives us a value. So let's just grab our calculator. So the calculator here will tell us that, well, let's see what we have. So we have, it's 4 times 7, it's going to be plus, it's a negative 3, so it's a negative 3 times 2, okay, plus 4 is going to give us a value of 26. So it's 26 on the top here, so it's 26, which needs to be divided by, well, 4 squared is 16, minus 3 squared is 9, 16 and 9 is 25, so it's the square root of 25 here, okay? So it's actually 26 divided by the square root of 25, which is the same as 26 divided by 5. So when we divide 26 by 5, we get a value of 5 and 1/5. So the distance d, therefore d is equal to 5 and 1/5 units, okay? So that's important. So there you go. That's all we had to do there in this particular case to calculate the distance between a point and a line, and more importantly, the perpendicular distance between a point and a line. When we were given the line, okay, so we're given the line in the form ax plus by plus c. There you go, ax plus some y plus c is equal to 0, and we're given the point x1, y1, okay, and we calculate the perpendicular distance using the formula for the distance. Sorry about the noise there, someone came into the office there just to do something, but anyway, that's how we do this particular calculation. So guys, once again, thanks for watching. This was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video was in some way intuitive, and more importantly, I hope that was helpful for you, and thanks for watching. Okay, bye bye.